Yeah, it's 3. So 3 goes out. What is the cube root of x times x times x?
X.
So 1x goes outside, and then what's inside the radical is just a 2. So that's the answer. Okay. Next question is the B. You have a square root of 10 divided by square root of 3. First, you're going to split that. First, you're going to split it. Okay. After you split it, you see that you know that you cannot have a radical in the denominator. This is not okay to be simplified. So you need to think about how to get rid of this radical 3 in the denominator. What do you have to do?
Multiply by root 3 again.
Correct. Multiply by the same thing in the numerator and the denominator, because whatever you do to the numerator, you have to do the same thing to the denominator as well. Now we just do the math. Radical 10 and radical 3, that goes together in one radical as 30 and it's not a perfect square, and there is no perfect square within 30 as well. The denominator is just a 3. So that's it. You cannot do anything with the 30 because there is no perfect square in 30. Okay. The next question is, you have a sum in the denominator, right? You have a sum in the denominator, which is 1 plus radical 3. When there is only one thing in the denominator, it's not the sum, it's just one radical, you know that you just have to multiply the top and the bottom by that. But how about if you have a sum of radicals, or the difference of radicals in the denominator? How do you get rid of this? Look at the example we did. What do you have to do?
You multiply by 1 minus root 3.
What is that 1 minus radical 3 called?
Conjugate.
Conjugate. Okay. Are you all with me? Okay. So you're going to multiply the numerator and the denominator by the conjugate of the denominator, which is 1 minus radical 3. And we are going to just multiply this. And this is 1 minus radical 3 times 1 plus radical 3. The numerator is, let it be like that. Don't distribute it. It's okay. What is the denominator?
-2.
Yeah. How did we simplify the denominator?
You can use a squared minus b squared.
Correct. Do you see that this is in the form a minus b times a plus b? Right? So what is a minus b times a plus b?
A squared minus b squared.
Okay, and a is 1. So 1 squared is 1. B is square root of 3. What is the square root of 3?
3.
3. The square root just vanishes. So this is going to be 8 times 1 minus radical 3 divided by -2. So you can simplify this -2 and 8 as 4. So that just becomes -4 times 1 minus radical 3.
Wait, Miss Mohandas, are we gonna have tests?
Yeah, this Friday.
Oh, okay. So on the test, do we have to write it like in that format, or will it also be correct if we just expand it?
Correct. I didn't hear the last part. Correct it what?
Will it still be correct if we expand it, or do we have to keep it like that in that format? The answer.
No. Yeah, this is okay. This is fine. Hey, but then Joel, the test is from chapter 8, not from 9, okay?
Oh, okay.
Yeah. Okay. So -4 times 1 minus radical 3. Okay, do you understand all these?
Yeah.
All right, okay. There is one more. Oh yeah, there is one more problem in the lesson. Let's do that. Okay, question D. Yeah. Oh, do you guys remember like radicals? Look at all these examples here. Like radicals should have the same radicand and the same index. Same index and same radicand. Radicand is the thing inside the radical.
Wait, Ms. Mohandas.
Uh-huh.
Are you gonna did you post the last time's meeting? I think I might have accidentally forgotten to go there for these problems.
The videos are all there.
Okay. Cause like I checked and the most recent one on Google Classroom, I was in that meeting, but I think there's another meeting that I didn't go to because these problems, I don't remember doing these problems.
Okay, now I remember that one of the video recording, I lost it.
Oh, okay.
I don't know if it was you guys or my calculus one. I remember one, I lost it because I thought I saved it, but then it just like vanished.
Okay.
Okay, but what I can do is like maybe I can put the PDF of this notes, so it is there.
Okay, thank you.
Yeah, okay, yeah, no problem. So radical 7, inside it's radical 3 plus radical 48. So we are going to simplify this. Like this. Now we can put them together in one of them. So that's 21. What is 7 times 48?
338. Oh no, 336.
336.
Time to pull out the calculator.
Okay, no, that's correct.
Oh, okay.
Joe, 3. Okay, so if you look at the 21, is there any perfect square you think as a factor for 21? Even if you try to do the factor 3, do you think we have a perfect square within that?
No.
No, right? Which means don't try that, but let it be there. Now we are going to definitely do the factor 3 for 336 because that's a little too big to do it in your head. Okay, you're starting with, what do you want to start with? 2?
3.
2. Oh, 3, okay. 3. 3, okay, so that's going to be?
112.
Okay, now 2.
56.
2.
28.
Oh, so 2.
14.
2.
7.
7. So 336 is actually
2 power 4 times 3.
yeah, so 2 times 2, I just write this 2, 2, 2, 2, 3, and 7. Did I put everything?
Times 7.
Okay. Okay, now I'm going to look for the factor because we are taking the square root, we're looking for pairs. So here you go. So 21 all by itself. One of the 2 from here and one of the 2's from here gets out. So what is the number that's going outside?
4.
4, good job. What do we have inside?
21.
21. Now can we combine them?
Yeah.
Yeah, they are like term. When you don't see a number, it's 1. You guys already know that. They both have the same radicand, 21, the same index. Both of them are square root. So they are like terms. So we can combine. So the final answer is 5 times square root of 21. So 5 times square root of 21. Do you understand? Everyone?
Yeah.
Yeah.
Okay. Guys, again, there's only 11 kids who joined today also. It is in school loop. I'm assuming that whoever, can you guys let people know that there is a Friday test coming this Friday?
Yeah, sure.
Like,
Like-
whoever in your contact or Facebook or somehow, because I don't know how many of them are actually checking school loop. The only time they're going to check when I put a 0 for the test. By then the test is over.
Miss Mohandas,
Mm-hmm.
my English teacher said that there is Thursday and Friday are like work days. I mean, they're like for the teacher that they learn.
That's true. Do you guys want to take it Monday then?
Yeah.
Which days are 30th and 1st, Thursday and Friday? Okay, so I will postpone that to Monday then, okay?
Uh-huh.
How would that test work?
How would the test work? It will be online, and then you will have a designated amount of time to do it. And you're all going to log in like exactly like a Zoom meeting and take it instead of, and then, yeah.
Okay.
And then I want you guys to turn on the video as well. The direction I will let you guys know as we get close to there.
Okay.
Okay. Okay, so we are done with 9.1. Let's do a little bit, maybe at least two problems from 9.2. Okay. So going back to 9.2 is right here. Okay, here you go. 9.2. I want you guys to read it, the first part. Good that it's coming back to quadratics because we did a lot of things with quadratics. You guys read the first part with the 3 points. Okay, so you all know that the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0, where a is not equal to 0, right? If you want to solve a quadratic equation by graphing, which most people don't do it because it's easier to do the factoring and stuff like that to solve it. But then because this is a lesson, I'm just going to show you guys how to solve by graphing. Okay. You're going to write the equation in the standard form. Make sure that the right-hand side is 0. Then you graph the function. Then you look at the x-intercepts. X-intercepts are the zeros or the solution. The solutions, the roots, zeros of all these are actually the x-intercepts of graph. In other words, all these things mean the same. So I want you guys to write it down. The solutions, the roots, the zeros, x-intercepts all mean the same thing for a quadratic equation in different contexts. If you talk about x-intercepts, then it's going to be a graph. If you talk about solutions, then that's going to be just an equation. But they all mean the same thing.
Wait, what were the three x-intercept solutions, and then what was the other name? Oh,
It's on the screen, yeah. Okay, so let's take a look at this. The first example, x squared plus 2x is equal to 8. Okay, now I'm just going to be honest with you guys here. Tell me, how did we graph in the beginning of chapter 8 when you were asked to graph the quadratic equation? Can someone answer the first step? Like, what did we do to graph this?
And the vertex, right?
Okay, you can find the vertex, that's correct.
And then find zeros.
And then find the zeros, okay. Which is exactly same, but they are asking you to find the zeros using graphing. You see what I'm saying?
Yeah.
So it's kind of, we know how to solve it, but now they're asking you to graph it and then solve it. But, you know, nobody will know how you're doing the problem on a test. So what I'm thinking, if you think you can factor this easily, go ahead, factor it, and then graph it. It's just the opposite of what they're asking you to do. But then I think that's okay. Okay, x squared plus 2x minus 8. Factor it, please. What are the factors? Okay. Hey, is this time conflicting with any other class? You guys know? Because Risha and some people who used to come regularly are also missing today.
As far as I know, I don't think so.
You don't think so? Okay, yeah, then it's okay. That's fine.
No, I'm pretty sure there's nothing during this time.
Okay, very good.
There might
Okay.
be a Spanish class going on.
Because you know, Jasmine, Risha, they used to come for every class, but they're not here
No.
today. So just wondering if it's.
I think Risha only had something today. She texted me. I think it's only today.
Only today. Okay, maybe Jasmine also then has that. Okay. Okay, no problem. Just checking. Okay. So do you guys think you can easily factor? This is just the x method. You don't need the box because the coefficient, leading coefficient is just 1. Right? So -8 goes here and 2 comes here. And you think about, are there any factors that add up to, are there any numbers that add up to 2 and multiply to -8?
4 and -2.
4 and -2. So the factors are x plus 4 times x minus 2 is equal to 0. And now you can find the intercept. So basically, just to know that we're just doing the opposite of what we are asked to find, okay? We are so solving first and then graphing. It's kind of cheating. So then x plus 4 is equal to 0 and x minus 2 is equal to 0. So x is equal to -4 and x is equal to 2. Now you know that these are the zeros, correct?
Yeah.
These are also called the x-intercepts. Is that correct?
Mm-hmm.
These are also called the solutions. These are also called the roots. These are also called the zeros. These are also called the x-intercepts. Okay, now just plot this. 1, 2, just, okay. 1, 2, -4, and then 2. Okay, now we also need to know where is the vertex. Can you guys tell me what's the vertex then?
1, -9.
X is equal to -b over 2a. What is -b here?
-2.
Divided by 2, which is -1. So the x coordinate is -1. Okay. Do you guys remember these?
Yeah.
Okay. And how about the y coordinate?
You just plug it back in.
Yeah, plug it back in and tell me what's the y coordinate.
-9.
So the vertex is -1, -9. I'm just going to say it somewhere here. Okay. So whatever the x-intercepts is the solution. Solutions and x-intercepts are the same thing. Okay. Next question is this. You're going to get everything on one side. First, you can find the x-intercepts by factoring. See if it is easily factorable. Find two numbers that add up to 2 and multiply to, sorry, add up to 4 and multiply to 4.
Two and two.
That's correct. So you have x plus 2 times x plus 2 is equal to 0. You take the first factor 0, the second factor 0, and you end up getting the same answer.
Wait, how would you graph that if there's only one x and it's
Yeah, so we need more stuff to graph here. So basically we have one x-intercept, but it's just repeating. Okay, let's just find the vertex. Okay, what is the vertex? The x coordinate is negative b.
-2.
Okay.
-2.
Oh
Yeah,
yeah.
now the vertex is -2. Plug it in. Tell me the y coordinate.
-2.
Okay. So now when you have a repeating 0 like this, a repeating intercept, you kind of know that's going to be the vertex. That point is going to be the vertex, okay? All right, so the graph is going to just look like something like this. But if you read the question is asking to find the solution. So you can write solutions is equal to x is equal to, what is the solution here?
-2.
Correct. Solution is the same as the y x-intercept. So x is equal to -2.
Wait, Mr. Hondas. The vertex is -2, -2, right? So doesn't that mean like the vertex should be 3 and it's down?
No, is the vertex -2, -2?
I think I did something wrong.
Yeah, I also think so. Check one more time. I did not notice that. Okay.
Oh, I see what I did wrong.
What
it's
is the
supposed to be 0, I think.
Yeah. Is Joel the only one doing? Hello, how come nobody fixed?
Yeah, I got 0 too.
Okay. Okay. So when you have these repeating x-intercepts, that's going to be the vertex. And so there is only one solution here, which is x is equal to -2. So the first example, we got two solutions, two distinct ones, they were different. In the second example, we got two solutions, but they just happen to be the same thing. So we end up with just one solution. These are two distinct ones. Over here, we end up with one distinct solution. Okay. Let's do another graphing. -x² is equal to 4x plus 8. You want to make one side 0. How about let's add x squared to both sides and make this side 0. Okay, so you're taking the negative x squared to the other side and making that side 0. It doesn't matter which side you make 0, but I thought we can make the negative x squared a positive one. Okay, see if we can factor this.
Oh, it's not factorable.
It's not factorable. So remember that sometimes you end up getting a quadratic equation where it's not factorable easily. I'm going to go with the old way of graphing. Let's find the x coordinate of the vertex first. So the x coordinate is going to be negative b divided by 2a. Go ahead, find the negative b divided by 2a. And I want everyone to find it.
Oh, it's -2.
-2.
Everyone is at -2?
Yeah.
Okay. Now the y coordinate. Y coordinate is
4. It's 4, right?
Yeah, let's just wait for one more person to finish.
Okay.
Wait, do you plug the x into the original equation or the standard one?
Either one is fine. You'll get the same answer. No, original one won't make sense because it says equal to, right? So just plug to the standard one.
Okay. Yeah, it's -4.
-4. So therefore, vertex.
Wait, it's 4, not -4.
So this is 4. This is -8. It's 4. So the vertex is -2, 4. Do you guys agree?
Yeah.
Okay.
Yeah.
So plot the vertex. Let's plot that first. -2, 1, 2, 3, 4. That's the vertex. Okay, that's not enough to graph it because we couldn't factor it. That was easy, but we couldn't factor it. Okay, tell me the y-intercept. How do you find the y-intercept if the equation is in the standard form?
You plug in 0 for x.
Or it is always the constant. It's always the constant term in the quadratic equation. That's the y-intercept. So what is the y-intercept here?
Oh,
0,8, right? Okay, so let's plot that. I'm gonna think that I'm just gonna say it's right here, but it's definitely not because the other places are all taken by the prints. Okay. What else? Okay, now this is the axis of symmetry, so you know that you are going to have something here. So you can graph it. Now tell me, so the graph is done. How do you solve by graphing? By looking at the graph, how would you solve a quadratic equation?
Wait, if they give you the graph?
Yeah, because we graphed here, right? The direction says that you have to solve by graphing. And my steps told you graph and then find the x-intercepts. Do you guys see what I'm trying to say now? Okay.
Yeah.
We graphed it. We graphed it. Now, as part of solving this equation, you have to look at the x-intercepts. What are the x-intercepts?
There is none.
There is none. So what does that mean? If there are no x-intercepts, then what do you write if the direction says solve by graphing?
No solution.
No solution.
No solution. So you can say that no X-intercept. Therefore, no solution. Okay, do you guys get it?
Yeah.
So that is how it's going to be. I'm just going to go over the 3 problems one more time. Just watch and listen. We are asked to solve by graphing, but we took a different attempt to do the problem. Whenever the function was easily factorable, we actually factored and found the X-intercepts and then graphed it. Okay, and then graphed it. So from the graph, solutions are the X-intercepts. So the solutions to this problem is -4 and 2. Second example was also easily factorable. So we factored, found the X-intercepts, but that just happened to be one distinct X-intercept. And that's the vertex. So there is only one solution. One solution. In the third example, we couldn't factor it. So we actually graphed it as usual. We found the axis of symmetry. We found the vertex, the Y-intercept, and then flipped the Y-intercept across the axis of symmetry to get the third point. And then we graphed it. But this graph doesn't have any X-intercepts. It's far away. Since it doesn't have any X-intercept, there is no solution to this equation. So now you know that it's possible to get 2 distinct solutions. It's possible to get only one distinct solution. It's also possible to not have a solution at all. Okay, are those examples clear?
Yeah.
Okay. All right, and I think that's enough for today, and I'll see you guys Wednesday at the same time, 11:45.
Wait, so Miss Mohandas, you'll post the notes, right? So I can.
Yeah, I know. I have to remember. I will do that. Yeah.
Okay, thank you. Bye.
Bye.
What's the whole thing about school not being there on Thursday and Friday?
It's PD again. Remember, right before the spring break, teachers had 2 days of PD, and then where the lecture was optional.
Oh,
It's
is
like
that like every week or like every other week or something?
I'm thinking this is probably the last one.
Oh, all right.
Yeah, I don't know if they're going to give more, but then this is the second time. So this Thursday and Friday, we are not meeting this Friday. And then I was thinking about a test, but I'll postpone that for Monday, okay?
So no classes will be taken on Thursday and Friday?
Depends on the teacher. They said it's optional. So if somebody needs to finish a lot of things and if they want to keep a meeting, they can. But I guess we are good, so it's okay. Unless you guys want to come. Why don't you guys study for the test, okay?
Yeah.
Okay.
Wait, Miss
Okay.
Mohammed,
Bye.
Yeah, bye.
are you
Yeah.
gonna start posting your meetings on School Loop to like make more people come or something? 'Cause you were saying like not many people are coming. More people check School Loop than Google Classroom, right?
But remember the first email I sent with all these like things, that was a School Loop email, right?
Oh yeah.
Yeah, I'm thinking of maybe sending one more to all the parents and all the kids one more time. I have been thinking about that. Yeah, I can do that.
Oh yeah.
Yeah, but you guys also tell people, but I don't know like why so less number. My calculus kids are more than this, but they don't have to care about my class because they are all graduating and leaving. But then Algebra 1, this class is very important. I don't know what these kids are thinking.